Hi, okay, welcome to session 12. This is the last one. So we're going to learn a little bit more about simultaneous equations, which is why I've done the recap the way that I've done it. I've just got a couple of things. Our next session together is consolidation. So trust me, we are going to see everything in a big way. So we don't need the recap particularly today. So if you can press pause and solve the simultaneous equations and draw on the same graph, the straight line graphs that I've given you there, and then hit play when you are ready. Okay, so I'm just going to quickly mention the graph. You should know that the y-intercept obviously is -3, so you could have put a little cross there. You've been told the gradient is 2, so put it over 1 and you've got your rise and your run, and you can just obviously go along 1 up 2, go along 1 up 2, and so on. Okay, with this other one, you had obviously an intercept at 2, and then your gradient is already in a fraction, which is always handy. So you've got a rise of 1, a run of 2, but you've got to make sure you are negative. So you've got to be running along and going down. So I'm running 2, going down. So that one, running 2, going down. I could always go up and back if I wanted to extend it in the opposite direction. So the skills that you've already learnt about these graphs, you can just apply without having to do very much more, to be honest. This is another way of drawing it. You set out a table and you substitute in, which is the way that we initially introduce and learn and develop this topic. But obviously with the skills that we've been doing across this course, that should be fairly straightforward for you. So this is what the final answer looks like. So you've got the two equations solved simultaneously, so y equals 1 and x equals 2, and you've got your lines. Now, the reason for this is because I wanted to show you something. I want you to look at the coordinate here of where the lines cross, okay? They are crossing at coordinate 2, 1. Now, remember, along the corridor, that's the x-axis. Up downstairs, that's the y-axis. So on the x-axis, I have 2, and on the y-axis, I have 1. Okay, now take a look at your simultaneous equation that you solved. For the x, you have 2, and for the y, you have 1. So the solutions that we have found algebraically for x and y are the coordinates of the crossing point between these two lines. Okay, now this is y. If I take the first equation that I drew, which was y equals 2x minus 3, if I was to pick up the y and just drop it on the other side, it would have to land as minus y, wouldn't it? So I've got nothing on this side now. I've got 2x minus 3 minus y. Now, what if I just pick up the minus 3, drop that on the other side? That would land as positive 3. And now I've got 2x minus y. If I just switch that the other way around, 2x minus y equals 3, can you see how this equation rearranges to this equation, which is exactly how they're given to us in simultaneous equations? Simultaneous equations are just rearranged versions of y equals mx plus c. I hope I'm blowing your mind right now. They are the same algebra. They're the same equations. Everything about them is the same. So simultaneous equations are linear equations. They can be graphed to give straight lines, which means we've got two ways to find solutions for simultaneous equations. We can either use our algebraic method, or we can graph the lines and just look to see where they cross. So if I was asked to solve the simultaneous equations that had been given to me in a graph, then I would be saying x is equal to 2 and y is equal to 1, because that is the crossing point. And that is this session, just getting our head around the concept and idea that these two things are actually the same thing, okay? So our first question is to solve graphically. So you'll need obviously your axes and everything set up, but you're going to solve graphically 3x plus y equals 6 and y equals 4x minus 1, okay? So think about this one here. All right, if you rearrange it into this form, it should be a pretty straightforward one to do. And when you've had a go at that, hit play and I will show you the answer. Okay, here's the answer. So this equation, 3x plus y equals 6, rearranges. This will land as minus 3x. And then if I put it in the order that I like it in, I'll have my minus 3x at the front and plus 6. So really, I am just crossing at the plus 6, and then I'm making sure I've got a gradient of 3 that's negative going through here. So that was the way that I could get the blue line drawn fairly easily. But I do want to show you something that I think's really useful to know, because sometimes when you rearrange, it can get a bit messy, and it's not always as easy. I would disagree to say that it would, you'd come across a time where it would break down and it wouldn't work for you. That's not true. You can rearrange and you can just follow the rules of your gradient fraction that you have and crossing point. But this is really nice, and I want to share it with you so that you're aware of the method. So the second question, obviously I wouldn't mess around with at all. That's y equals mx plus c. It's super, super easy. I'm just plotting it. So we're not talking about this one. But what we are going to do is look at an alternative way to rearranging. Rearranging works, and you do that if that's what you like. If you want to play around with this idea, then you will have a go and play around with this idea, and it will really be your choice. But what I'm going to do is I'm going to use the 0 to help me find a couple of coordinates, okay? So if I was to say that my x was going to equal 0, so this is my coordinate. Remember, my coordinates are x, y. So if I'm saying x is going to be 0, I've decided it, it's going to be 0, then my 3x, 3 times 0 is 0. So it as good as disappears. I've got 0 plus a number that y will take equaling 6. And y obviously has to be 6 to make that true. And I've just found a coordinate that sits on the line. I have just found the coordinate, and I'm going to change the color I've got here, of 0, 6. Can you see it's that point right there on the blue line? So I'm going to repeat that process now. So I'll rewrite 3x plus y equals 6, but this time I'm going to set my y to 0, which means I don't know my x value, but my y value will be 0 because I have decided it's going to be 0. Okay, so that now gives me 3x plus 0, doesn't do anything, does it, equals 6. So 3 times something equals 6. 3 times 2 equals 6. So my x has to be 2. So if I plot the coordinate 2, 0, then I'm right there on the blue line. Now, all I need to do is just get my ruler, line it up between those 2 points, boom, done. So it's just an alternative way of thinking about how you could plot these lines. And it's quite nice. I think it's good to know it exists. Okay, next question. Entirely up to you how you choose to have a go at it. But I want you to find the solutions to those simultaneous equations graphically. Okay, there's your answers. And I'm going to go through the whole 0 thing again, just in case there is some out there wanting to give it a go and wanting to just check that what they're doing is right. So for my 2x plus 4, whoops, joining it up and it's not making sense. 4y equals 8. I'm going to set this to 0. So that's not there anymore. I've got 4y equals 8. So 4 times 2 equals 8. So when x is 0, y is 2. And then I'm going to do the same. I'm going to set the y to 0 this time. So that is now 0. And I've got 2x. There's nothing there. It's not even worth showing it. Equals 8. 2 times 4 equals 8. So x must be 4 when y is 0. So checking in with that. The first coordinate, 0, 2, is slap bang there. The next one is 4, 0. It's there. Put your ruler in, draw your line. The only time I would say it's not useful is if those points are too close together. All right. You may not get the ruler completely at the right angle if they're really close together. But other than that, it's quite a nice little thing. The other thing that I would say is at foundation, it's more common to be asked to solve the simultaneous equation from a graph that's already done for you. You don't even have to draw them. It's literally done for you. And really all they're testing is, do you know to look at the coordinates of the crossing point? So it doesn't really get you a huge number of marks, but it is another mark you are getting for having that knowledge. Higher, it is more common for them to have a higher expectation of you drawing it all from scratch, if you were to see a question like that. Okay, so we've got another one just to check in and make sure we've understood it well enough, and then it's straight into practice on this one. Okay, so hopefully you paused and now you're back. The answer is as follows. Okay, I'll do the setting to 0. Like I say, just in case you're interested in how that's working and you want to just check in with your work, you'll know that it's gone well, really, if your line is in the correct place. But if it hasn't gone well, then you're going to want to know, aren't you? So I've got 2x plus y equaling 6. If I put this to 0, then y has to equal 6. So I've got the coordinate 0, 6. When I set the y to 0, I'm going to have 2x equals 6. 2 times 3 is 6. So 3, 0 is your other coordinate. Okay. Right, that's it. There's not a lot more to share with you. Either use the whole setting to 0 or just rearrange. Just rearrange. It's easy to do it that way. Okay, I'll scroll down slowly so that you can sort of see all the questions if you're working from the screen, and then I'll do the same with the answers. And then that is it for learning. We're done. So massive well done for getting to the end of the course. There is a lot of content and it's not easy. So really your measure is not about whether you are 100% perfect. Your measure is how much additional knowledge, how much progress with my maths have I made since the start of this course to where I am now. Okay, and please remember, you've got this course. You can go back, you can look at individual tutorials if you just want to brush up in one little thing. You can redo the consolidations anytime you like. So it's all there for you to use as much as you need to. Okay, I'm disappearing and I will see you next session.